Hello there, Cardinals. It's me, Mr. Ernst, and in this video, we are going to be talking about transversals, which is this thing. Transversals are this thing. Essentially, it is two parallel lines, one parallel line, two parallel lines, and the transversal is this line that kind of cuts across the two of them. And these guys are important just because of the relationship that they make with these parallel lines. And we're actually going to talk about how this kind of plays out. Because right now, I know that this little angle up here is said to be 36 degrees. And by the end of this, we're going to find all of these missing angles, all 7 of these missing angles, using just that 36 degrees. But before we get there, we kind of got to go back a little bit. Let me see. We're going to go back and kind of talk about something else first. Before we get to working with the transversal, we need to talk about supplementary angles. Okay? So supplementary angles are these things right here. In other words, they are a straight line. We have this straight line right here that is cut into two different parts. So this is kind of cutting this into two different parts. Remember that a straight line has a measurement of 180 degrees. That is key because supplementary angles means we have two angles that make up 180 degrees. Well, that makes our life kind of easy because we know that this total from here all the way over to this side is 180, and we have 36 right here, which means this angle here must be the remainder. So we just do 180 minus 36, which should be, let me see, hold on, 144, I believe. 144 degrees, let's see, 6 plus the 4 gives me 50, plus the 30 gives me 180, so 144. And I'm even, I'm going to be paranoid and actually double check this on a calculator like a big nerd, because I don't want to make a mistake on YouTube. Yes, 144. So once again, to find that, what I did was 180, because I know my calculator didn't pop up on the screen. 180 minus 36, and I got 144. And that was my remaining angle over here. Whoop. So I know that this angle right there is 144. I can erase this. Alrighty. And I'm actually going to erase this too. Because now we have one angle down. So what I'm going to do now is I'm actually going to kind of erase this next part here. The next part of my transversal, okay? So now what we're looking at, I'm going to be trying to find this angle right here, okay? Now, again, what we're looking at is here's a straight line, which again is 180. And again, from here to here, for a straight line, still needs to be 180 degrees. So I have this angle right here is 144, and I'm missing this angle right here. But I know that 144 plus whatever this angle is right here has to add up to be 180 degrees, which means that this angle down here is the same as this one, 36 degrees. Because 144 plus 36 is going to give me this straight angle. 144 and 36 gives me the 180 that I need. So now we have 3 angles down. While we're at it, let's go ahead and get the other side here. Again, once again, we have a straight angle. And we know that from here to here from here, draw that out just a little bit more. From here to here has to be 180 degrees. Again, because this is a straight line. It's at an angle. It's kind of tilted right now, but we know it's still 180 degrees, which means that this down here must also be 144 degrees. So now we got 4 down. So I'm going to actually start erasing out for the next part down here as we're kind of going. Cool? So now we're kind of slowly, as you can see, slowly kind of getting the rest of this transversal finished up here, okay? Now, this is kind of a key part, and this is actually where our where our transformations come in, specifically the translation. Because, for example, this angle right here, we know that that angle is 36 degrees, correct? Now I'm going to grab that angle and I'm going to translate it down. I'm kind of scooching it around, right? I'm just sliding this angle around. And we know that because I'm sliding this around, just because I'm moving it, doesn't change it. This is still 36 degrees. I know it's still 36 degrees because I can grab this angle and put it right back into that corner, and look, it fits perfectly. So, the cool thing with this is I can actually use this to figure out where another 36 degree angle is, which happens to be right here. See how nicely that fits in there? I can see that this is also 36 degrees. So I'm going to go ahead and write that in there. 36 degrees. I can also, coming back to this, when I've got this 36 degrees, I can still rotate this and it is still going to be 36 degrees. So I've rotated it 180 degrees. Again, this is where our transformations come in. We've translated and we've rotated. So this is still 36 degrees. And I can actually come down here and see that this angle down here is also 36 degrees. This is another proof that this is also 36 degrees. So once again, I know that down here is also down here is also 36 degrees. Now this works for both angles. It is not exclusively that 36, because if I grab this angle here, it is very important that I get this angle correct. Because otherwise it's just not going to fit. 1 and 1. So if I grab this blue angle, my 144, once again, I can slide this away. I do know that this is still 144 degrees. Cool? And again, I'm translating this. I'm translating this just like we translated the other shapes. This is 144 degrees. I'm going to translate this down here. And look at that. It happens to fit right down here, the 144. So I know that this is also 144 degrees. Now something I want to mention. Something I want to mention about this is the fact that this is not going to fit wherever I want it to. For example, I can try and rotate this to try and get it to kind of fit into this spot here, 36 degrees. But as you can see, this 144 is an obtuse angle, and it's not going to fit in this 36 degree thing. No matter how much I try and rotate this thing, it is not going to want to fit in that spot. It's just not going to work. So I'm not trying to force anything here. I definitely want to make sure that these things are working well. Okay, so I'm going to go back to its original spot here, right about there. And do the 180. Again, I'm rotating it 180, and once again, I'm going to translate it. And boom, look at that. 144 fits nicely right into this little corner once again. So I know that this corner down here is also 144 degrees. And that is just a very bizarre kind of phenomenon that happens with transversals. Is that this thing looked like it was a lot of work, right? 7 different angles we had to find, but realistically, it was only these two, 36 and 144, from our original straight angle, from here to here and here to here. In fact, if I was to take that straight angle right here and right here, I can actually take this entire straight angle and move this down, and it's still going to line up. 36 and 144, it lines up right here. And even if I take this and I rotate it, again, this is the purpose of us learning the rotations and the translations and all that stuff, so we can use it. If I take this and, oops, I messed this up. Line this up with this one here. Actually, line it up with this one. Hold on, what's going on with this? Oh, that works, yeah. Line this up with this. It still does the same thing, 144, 36. Slide this down here, 144 and 36. No matter what I do there, I forgot to rotate it 180. That's why I wasn't seeing it working earlier. And again, I could grab this and put this right here as well. So again, translating and rotating by 180 degrees, we are finding all of these different relationships, and that I was able to fill in this entire transversal because I knew how a supplementary angle worked. From one side to the other, it adding up to be 180. And then I was able to use that to fill in all of the other sides, okay? So notice a couple of different patterns here before we finish this off. A couple of patterns. First of all, diagonals have the same values, okay? And then these ones also have the same values. Boop, boop. So, but yeah, that's how you solve a transversal. And the coolest thing about this is that the transversal could be as big as you wanted it to be. This could be an enormous transversal that is just really, really super big, but you're always going to know all of these angles. For example, this is going to be 36. This will be 36. This will be 36. This will be 36. And then all these obtuse ones are going to be 144, 144, 144, 144. Even if I was going to add a second transversal, if the second transversal was also parallel, if the second transversal was also parallel, then this pattern continues. 144, 144, 144, 144, 144, 140. And now my writing is getting more and more sloppy as I go. And then all these little acutes are 36, 36, 36. It does not matter how big this transversal gets. It is always going to be the same two numbers over and over and over and over again. Okay? So that is how you can find missing values on a transversal. Thanks for watching.